Hello everyone, and welcome to Tech to Science podcast, the Earth, Space, and the Human Race. I'm Kavya,
And I'm Abigail.
and in this fifth episode, we're talking to two experts. One is a space researcher and communicator, the other is a space entrepreneur and industry expert. So, we're going to talk to them about where India is headed in the space exploration of the inner solar system, from the Sun and Venus to Earth's very own orbit, the Moon, and Mars.
So joining us today is Jatan Mehta, who's an astrophysics graduate, a ex-science officer at Team Indus, and he's now a writer, a researcher, and a public speaker who's passionate about space exploration. Also with us today is Narayan Prasad, who's currently COO at SatSearch, a global marketplace for space products and services. He's also the co-founder for Dhruva Space, a private player in India's satellite industry, and he hosts his own science podcast that is on its 34th episode as of this recording. So, Narayan, Jatan, I know you'll put out your own space content. Where can people find it?
So thank you very much, firstly, for having me on this particular podcast. My content is basically just the boring podcast that people want to listen to if they're interested in space. And I guess I'm possibly the only show that I know that focuses completely on the Indian space scene, largely taking things from also the historic and the contemporary perspective, and not just making it just the praises for the space program, but more looking at it from a critical standpoint as to what we can do better. So the New Space India podcast is available on every other podcasting platform as anybody would want to listen. So and the whole idea is to just inspire a younger generation of people and possibly people in ISRO to change a few things for the better.
So, since I'm a science writer, I primarily write blogs for publications and on my own blog as well. So, people can find everything in one place at jatan.space. So, that's basically the link to my website, and you will find articles on planetary science, the moon, space exploration, the technologies behind it, human spaceflight, and so on. My idea with the writing that I do is, and I try to stick to that, is I want to cover the science bits of space exploration in general, because a lot of the coverage that is done is typically focused on the technology end of it, and I think that I see a gap in the science spectrum, and so that's basically what I want to cover.
Right. Thanks so much for making the time. I think both of you are pretty good communicators, and you guys have just the right kind of expertise for us to discuss what we're discussing today. So thanks for making the time for this. So we know that July 2020 in particular was a pretty spectacular month. I mean, we saw 3 missions to Mars, and these were from UAE, US, and China. We know that Mars is, of course, a very big deal. What are some of the other really sought after destinations in the inner solar system? Maybe Jatan, you can take this one.
Yeah, so apart from the Mars and the Moon, there are other interesting destinations. One of my favorites is Venus. After the space age, Venus got a lot of highlight, and there were many probes sent to Venus by both the US and the Soviet Union back then. But after that, it kind of dwindled. So in the last 2 decades, for instance, there have been just 2 spacecraft that have went to Venus, and so that's one of the interesting destinations, because we know from those past missions that Venus most likely hosted water on its surface for at least 2 billion years, and that's not something that you think about when you think about Venus these days, because it's hot, and it's basically not a very pleasant place. But it had surface water for about 2 billion years, and there are many such interesting things to find out. And it's an Earth analog that we want to study to better understand Earth as well. So that's why I think that's one of the most intriguing places in the solar system, in the inner solar system especially. Then, of course, there's Mercury, where there have been only 2 spacecraft that have ever went per se. One is a flyby from the US, and that's the Mariner 10, and the other is the Messenger spacecraft, which was an orbiter. And Mercury is very interesting in various ways. It helps us understand things about how planets formed that we have knowledge gaps on. very significant knowledge gaps on. So Mercury is also underexplored and is a very interesting target for the coming decade or two. Mars is of course there and the moon is there, so I won't talk about that. But the moon of Mars, which is Phobos, is less explored, and there have been attempts in the past to see as to what is going on in Phobos, because there are some things about Phobos that we don't understand. For instance, where did it come from? And we don't know its origin, and that has a lot to do with the past of Mars as well. So getting an orbiter around Phobos or a lander is something that would be very valuable. And yeah, and then there's a bunch of near Earth asteroids that are very interesting, but they are getting a lot of attention these days thanks to the Japanese Hayabusa 2 mission and the NASA's OSIRIS-REx mission, and so on.
Of course, it all then depends from a space policy perspective. It all stands on what is the combined perspective of policymakers in each country as to what they prefer. Because, for example, in the case of India, if you look at the Mangalyaan 1, the objective was more or less, I would say, a little bit more of geopolitics of getting there first against, when you look at China, for example. And the focus was not so much on science, I would say, and more on the technology demonstration side and getting the soft power objective of getting to Mars successfully first before China does.
Yeah.
So there is a little bit of that goes into space science exploration, and most often in countries like India as well. A lot of the funding comes from, of course, I guess, telling policymakers that we're going to do this for the first time or we're going to do that for the first time, and that attracts policymakers to fund a particular mission rather than saying, I want to cooperate with this particular country or so on. So there are some of these underlying dynamics on how space exploration can be driven in a certain different fashion.
Now that we're talking about like a little bit of politics in India, Chandrayaan 1 created like a big buzz when it discovered water on the moon. And that was like a really big thing for India. And then we have had a bunch of, orbiters and landers go back to the moon. And with NASA, their current whole strategy is back to the moon all the time. So what exactly does the moon have to offer in the grander scheme of things for space exploration?
From my perspective, it's quite simple. I think given that the moon can be a destination where it could be an outpost to do larger space exploration to other parts of the solar system. Just to add from a typical mission engineering standpoint, the moon, we have discovered water on the moon, but nobody can tell how much is the quantity exactly that is spread across the lunar surface. But then the exciting part is, of course, discovering the water underneath and the potential of exploiting that resource to do or to reach other places. So as of today, there are about several, tens of companies that are looking at devising water-based propulsion systems. And that is where, the excitement comes for when it comes to lunar surface water. Because typically what happens is you have to have a rocket that is big enough and the most of the money that is spent is in actually clearing the Earth's atmosphere. So the first 30-40 kilometers above us is the most difficult part of clearing in terms of building a space vehicle and taking stuff outside of the Earth. But then what if you could use the lunar outpost and you could use the resources within the moon's surface, typically water, for example, and you could produce fuel on the moon itself to actually use that as an outpost to then do a lot of logistical operations between moon and Mars and many other outposts. And that's the most exciting part, I would say, of the moon itself. Of course, people do make a case for helium-3 and existence of helium-3 and large amounts of quantity there and exploitation of that, but that I think is still a very, very far-fetched reality, especially in terms of how you could extract that and in quantities that make sense, and also how you could turn that into energy in a way that it makes scientific sense, as more than scientific sense, I guess, the engineering capability for it.
Just to expand on what Narayan said, there are destinations in the outer solar system, for instance, Ceres in the asteroid belt, which are easier to reach from the moon from an energy standpoint than they are from Mars. And that's not very intuitive at all, but that's how it is. And so basically, the amount of effort that we exert into taking everything out of the Earth's gravitational well is immense, and I don't think we can be doing that for a long time if we want to do things efficiently in the far future. So that's the long term aspect of it. In the short term, apart from the settlements part, there are of course science reasons to go back to the moon, and I think they are just as important, because the moon's airless nature, essentially the moon is essentially a dormant place more or less, and its airless nature and the fact that it doesn't have tectonic activity, which means that there are records preserved of the events in the past solar system that we can find on the moon. So it's sort of like an ancient archive, and we if we go back to the moon, especially in those regions where the water ice is, which hasn't seen sunlight in absolutely like billions of years, like at least 3 or even 4 billions of years, depending on how the geometry worked out. So those places are distinctive of what happened 4 billion years ago in the solar system. And this is also tied to not just the origin of the Earth and the moon, but also the solar system. Basically, what the water that comets and asteroids brought in the inner solar system in the early days is what is deposited in those permanently shadowed regions on the moon. That's the origin part, but there's also the evolution component, where if we want to figure out what happened in the solar system 500 million years ago, and then 1 billion years ago, and 2 billion years ago, and so on, those records are also preserved in the form of craters, which are practically untouched since their formation. The real deal, in addition to water, is the metal-rich nature of the moon. So we know, for instance, that there is substantial titanium in the form of titanium dioxide. So that can also be harnessed for settlement. So we see the moon as both enabling exploration and settlement, as well as solving fundamental questions, science questions about the solar system and Earth-Moon origin. Apart from doing both of those things, it also is a good test bed for technology for missions to other parts of the solar system. So before you would send a mission to Mars, it's much better to redo a human landing and reuse a lot of those technologies, or at least gain experience, operational experience in those things, and then move forward.
Next one's for you as well, Jatan. I'm curious to know, like, India has a lot of plans in the near future to explore near Earth inner solar system objects, including a third mission to the moon, a Venus orbiter, mission to the sun, maybe even a space station, which is a big deal. So what's the underlying kind of strategy that India is using to approach exploring the inner solar system? Like, is there some kind of method to this madness, or is it sort of just going with the flow as for what we discover and what is geopolitically important?
So there's two things to it. One is that if you compare it to to what we had 10 years ago or even 20 years ago, when we practically didn't do any planetary exploration at all, per se. In that sense, it's a very methodological thing, where we started off with a moon orbiter, and then we steered off to a Mars orbiter. However, apart from that, there's a lack of an overarching philosophy to string those missions together. And so what often happens is that there is a supply driven model, which is mostly at the core of these planetary exploration missions. So for instance, if you take a look at Mangalyaan, and so Mangalyaan was originally supposed to go on a GSLV rocket, but we know that the GSLV rocket in question could not be ready at the time for Mangalyaan launch, and for some reason ISRO wanted to do it earlier than let's say 2015 or something, which is what Narayan pointed out to earlier. And so they made do with the PSLV rocket, which meant that the spacecraft scope and capability of the mission gets reduced. That's also the case with many other missions, where essentially we see what kind of technologies that we already have ready, and if there's some delta that you could fill up easily, and then we sort of go about doing those missions. And this is in stark contrast to, let's say, the US model, for instance, where they have a mix of both. Of course, there's always going to be a supply driven component, but there's also a larger demand driven component, which is what the US terms the decadal survey, where they have a consensus report from the entire US scientific community, which is released every 10 years, which sort of prioritizes the scientific goals of each of those endeavors, be it a Venus mission or a Mars one, or experiments on the International Space Station and so on. So they sort of prioritize those goals in a way that represents a consensus, and then that is pitched forward. And then more often than not, the missions in the decadal survey tend to happen. So there is definitely a demand-driven component which is prominent, and so I think if we want to be pushing the boundaries further in terms of space exploration, and we have in certain ways, for instance, the Chandrayaan 2 orbiter is remarkable. If we want to continue to do that, then we need to be moving to much more of a demand-driven model.
So for Mars, there are two sides to the story. One where we want to look at its past, where we want to know whether there was life on the planet, or if it still exists. And one is which the picture that Elon Musk paints for us, where it's we are living on Mars and we're doing things on Mars. So which side does India lean towards?
Narayan?
I think it's an interesting question as such, because it really depends on what is our focus in terms of space science. And unfortunately, I don't think so. We have a stated statement that is official on what is our stand in terms of space exploration. We don't have a specific space exploration policy. If you look at what happened with India over the 70s and the 80s, there was a very specific focus on technology and how technology can be matured over 3 or 4 decades of time. And if you look at actually the space transportation roadmap that India has, actually the stated goals in space transportation may stand for another 30 or 40 years, because the goal of producing a reusable launch vehicle or tooth stage to orbit, or many other aspects of space transportation, they have been outlined very clearly in the space transportation roadmap that India has for the last 20, 30 years at least. They have been very clearly stated that this is what we are going to try to achieve over time. And so that gives a longer term perspective as to what is the future looking like. But unfortunately, on the space exploration and the space science side, we don't have such a long and drawn out architecture on where we are heading and what we'll exactly be doing in the next 30 or 40 years. So I guess, if we put our brains together and have all the, not just the ISRO community, but the larger space science community, the astrophysics community, and the whole exploration community kind of come together, there may be a possibility of creating such a roadmap where we have then set an overarching framework as to what will be India's specific goals in terms of space science and exploration for the next 20 or 30 years. And that also can give a signal to other countries who would want to partner with India, saying India has then stated its objectives in the next 20 or 30 years, and then they can themselves align their activities to see if there are synergies with respect to what we do. And through that, there could be a better collaborative approach to what we are doing in terms of either going to Mars or even other destinations.
And coming closer to home, the International Space Station, it's right here in orbit, and it's been an incredible effort for 20 years. A lot of partner countries in the US have kept it running and had people in space for 20 years nonstop. It's given us invaluable insight into what it takes to have humans healthy in space, how to work in space. What are the things that we're still unprepared for in that aspect, of having settlements, not just in orbit, but also on the moon and even other planets, Jatin?
So basically, there's There are a few things that directly translate from the experience gained at the International Space Station to the moon. So, for instance, living for longer periods in space in low or microgravity environments is definitely something that translates well, and that we have been doing for decades now. So, that's one thing. But apart from that, there are other things, for instance, like the radiation environment and the test environment on the moon, and on which is also similar on many other bodies of the solar system, is not at all the same to compared to the International Space Station. So the radiation component on the International Space Station, while a bit higher than on the surface of the Earth, is still substantially lower than one on the moon. And so if we want to say focus on habitats on the moon for long-term settlements and so on, we need to solve the radiation problem, and more specific to the moon, the lunar dust problem. So the lunar dust is essentially it's not a very pleasant thing. It's very fine and it can get into places. And there are talks by Apollo astronauts where they describe how difficult it was to get rid of the lunar dust whenever they went for excursions during their mission. And so that's the other challenge that we have to solve. And but apart from that, there's a much more larger technological component which I think is also in the building as we speak. Is one of the reasons why the International Space Station works and has been working remarkably well is because we have rockets and spacecraft that are reliable enough to be produced in a high enough volume at a high enough cadence that we can constantly supply, materials, food, astronauts, and so on, and bring them back and so on. So we have a reasonably high volume and cadence for the technology components that make up and maintain the International Space Station. But that sort of a cadence is missing for the moon if we want to go ahead and do it. So that would be the first step, to have uh, big enough rockets, because the moon is much further away, and landing on it would also cost extra in terms of energy. So to have big enough rockets and to have similarly big spacecraft with a high cadence that can continuously land on the moon or orbit. And then there's the one last component, technologies which allow us to use those resources on the moon and be able to do something fruitful with it without having to drag everything from Earth. So that would also relieve a lot of pressure from the Earth of having to constantly supply things to the moon. So I think those would broadly be the primary challenges.
The only thing that I would add here is that the way that we would explore other planets is, I think, by not involving more space engineers, but involving scientists from other streams. So what I mean is that you can only go so far by building rockets and building satellites and things like that. But you would have to involve people who are doing like biology, or people who are doing chemistry, and people who are doing really basic science efforts to allow them to do a little bit more in space. So if somebody says that we could build using some kind of regolith model that says that can help humans survive a better radiation environment, so those are, I think, the streams. But often the space science community, or the space technology community, it becomes a bubble, and I'm a part of that bubble. But it actually is the very wrong thing to do, because engineers can only dream and build things that are immediate and is the next step. But only if you effectively kind of involve the scientific community and have them do a lot of interesting experiments, and then have them drive a lot of technology development.
Just to add on that point, one very good example of that, I think, is the Mars exploration program from NASA, which they decided in the 1990s. So their goal essentially was to scientifically put it, and in a very simple manner, and that's what they stated officially, is follow the water. And the idea was very simple. You send missions that would look for signs of water and all the processes related and connected to that, and they would essentially lead you to the next mission as to what are your goals for the next mission. So you had a streak of orbiters in the 1990s, and the first rover, which is Sojourner, and then you had Curiosity and Spirit. And that has the specificity of the goals, science goals, driven by this Mars exploration program, which is primarily demand driven from the scientists working in the US, has led to substantial technological improvements, where to the point where we know how to land. The US knows how to land something on Mars, but not on the moon. So, but they can do the Mars bits very effectively. And if you look at specific parts of that technology stack, then you can see that they have been improving by orders of magnitude. So when the Vikings landed, for instance, back in the 1970s, we typically use the term landing ellipse, but essentially it means an error margin in, if you target a point X, then how far away can you will it probably land from it, given the errors that crop up in terms of sensors and whatnot. So the landing ellipse for the Viking missions was huge. It was hundreds of kilometers. So it's essentially like saying, okay, I will land somewhere in India. But with Perseverance, you are now saying, okay, I will land somewhere within 10 kilometers of this region where the water was flowing. So that's the sort of a difference that that science-driven technology can make.
Why can't India just collaborate with the ISS? Like, why does it need to make a whole new space station? What's stopping them? Is it just like a power symbol, or is it necessary?
There is no logic to who decides what in this, except some policymaker saying, I want to do my own station rather than collaborate with somebody else. Of course, the offer to join the International Space Station has been there for India for many, many years. I attended a ISS conference here in Berlin about 10 years ago. And even there, they were talking about other member countries to coming in and participating. And unfortunately, the model of ISS is very simple. It's like pay to play kind of model. So where you have to first pay up, and you have a certain amount of money that you can pay to play in that particular area of the ISS. And that is not very cheap as well, because I think the amount of money that the US spends and Europe spends and even Russia spends to keep up the space station is pretty high on a regular basis. And we don't know yet what will happen to the station, maybe 10 years from now, even 5 years from now. I think there's a slight agreement that we would go up to 2030 or something. I've not been following it up, but beyond that, I think it's very uncertain. So for me, I think the China space station that is happening, and the India one is more of taking cues with respect to what China is doing, and possibly being recognized as a power regionally, and then using the space station as a soft power objective to say that we can also be equally good in terms of technology. But what would be really interesting in the future is if India can be an active participant in the cislunar space, because especially that is an exploration space that is very exciting, where only now the US and the US based companies are really looking at investing cislunar activities, and how that could be interesting for human exploration as well. So I guess from my standpoint, instead of just thinking of what has happened with space stations over the last 50 years and just saying we'll also do the same things over and over, it would be interesting if India could say we'll not actually do the space station directly, but instead we'll directly look at doing something in the cislunar space, and something that is very new that nobody has done much of, or is also new for others as well. And that would be more exciting, I would say, from an India standpoint. And also I think that would signal to the international community that India is thinking more like a step function rather than replicating what China and US and others have done.
Speaking of which, I mean, India and China, India, we are neighbors, competitors, we are economic powers in kind of similar standings. Jatin, are both these countries' ambitions when it comes to space exploration comparable? Are they very different in how we think of space exploration?
From science and exploration standpoint, there is a considerable difference between the Chinese space exploration program and the scope of it, and also the progress of it compared to the Indian one, for instance. And it's something that I think we should not overlook, because a lot of the times when Indian space exploration efforts are covered. Parallels are not drawn either intentionally or otherwise to the Chinese counterparts. But I think that's worth looking, because especially, if we are thinking any way to do a Gaganyaan space station, for instance, we might as well follow the lead of China and see what they have done. So, for instance, if you compare the lunar exploration efforts, China started with two moon orbiters. One of them was before India. So they successfully did two lunar orbiters, and India did the same with Chandrayaan 1. But after that, after the Changi 1 and 2, which were the orbiters, China started with Changi 3 development, and Changi 3 landed successfully on the near side of the moon in 2013. And after that, instead of just repeating the same exercise and expanding the scope of the surface mission there, the interesting thing that they did, and I think that's a great example of what Narayan was speaking about earlier, of doing something distinct in terms of a problem, is Changi 4, where Changi 4 landed on the far side of the moon, and that was not just the first landing attempt but also the first successful one. So as we speak, both the Changi 3 landers and the Changi 3 and Changi 4 landers are functional on the moon right now, and that's something very interesting. So if you remember, the Chandrayaan 2 lander and rover pair were supposed to be alive on the surface for 14 days, 14 Earth days, which is basically one lunar day. And so that's because once the lunar night kicks in, you have very cold temperatures, like it goes as bad as minus 180 degrees Celsius at its peak. And that's not something that your spacecraft and or the rover can survive in that environment for a prolonged period. And that is where the mission essentially would have ended, even if we had successfully landed on the moon. But with both the Changi 3 in 2013 and Changi 4 in 2018, you make use of nuclear powered isotopes, the technology of which they built, just like the US has it and Russia has it, and that allows those missions, both the rover and the lander in the missions, to function for much more than one lunar day. So Changi 4 is almost has passed 1.5 years and is still alive and doing science and all such things. And Changi 3 is also barely alive on the surface, although we don't hear about it a lot. But that's sort of interesting that they have two landers on the surface. The Tianwen orbiter and rover pair that China has sent, assuming that it goes successful, then it would be a huge leap. Where even though India would have been the first country to orbit Mars, the orbiter plus landing and rover pair of China would be a considerable increase of scope. So that's the more or less the science bits of it. But there's the other part, which is China is also thinking about undertaking missions to the outer solar system. And so they are thinking about a Voyager class mission where they just try to cross the solar boundary and enter interstellar space and study objects in between. It is also on the way of building its third space station. They have already built two. So essentially, what we are trying with Gaganyaan, they have done that with the experience that they gained. Now they are building a much more larger modular space station. I think what we can at least do is just look at the Chinese model and the progress and the amount of resources they are putting into this, and try to replicate that, because it would help us grow faster in the related science and technology bits.
As compared to China. We're not going to go to like NASA at all, because I think NASA is doing things that ISRO can't do right now. So, as compared to China, do you think India's ambitions, their goals are very small, very low? They're much more lower than theirs.
So, yeah, I think with the exception of the Chandrayaan missions in general, and especially the orbiter parts, much less the lander, even though the lander was the highlight, I think the orbiter is doing far more interesting science. And the scope of the exploration is also larger in terms of the technology development for the instruments. But with that exception, I think in general, yes, we are aiming lower than the Chinese counterparts for space exploration. And I think there is enough room and capacity in the country to head higher. It's just a matter of, uh, us having a formal policy, which Narayan touched upon earlier, where we don't have a space exploration policy in the first place. And so that is the thing which is making these missions sort of one-off and not so wider in scope and not part of a program or something of the sort. So China actually has a process. So I talked about the US process earlier. So China has a similar process which is driven by the Chinese Academy of Sciences, and I think we have all the components required individually to enable that. It's just a matter of someone actually looking at it and deciding we should do that as well.
It's been almost a year since the US has started their Space Force, and I don't mean like Netflix's show with Steve Carell. And it's only a matter of time before other countries do the same. Will that put like a dampener on space exploration in general?
So, in fact, it might do the exact opposite, where you have more and more countries investing more and more in space. Because now what will happen is, after the US has come up with the Space Force, the Japanese have announced a very similar force that is looking at space from a military standpoint. We have a number of other countries, including Italy and others, now looking at a formal space force as well. And even within India, there was a proposal for the Space Command. And unfortunately, we don't have a Space Command. We have now a Defense Space Agency instead. The focus of more and more countries may be looking at investing in some very niche technologies that does not have an immediate civilian focus. But as we all know, over time, things trickle down into the civilian domain, and that is the best case for funding and seeding modern technologies and technologies that are not of immediate civilian interest. So as it is with the trajectory with the internet, the trajectory with many other Apollo based kind of investments, we should hope that the military investments in space that are happening today can translate into things like planetary defense, can translate into things like long-term presence of humans in outer space, can also translate into things like mapping of space debris and knowing the space environment in a real-time fashion in a much more capable manner. So I would say that is the way forward in terms of hoping that none of these technologies and none of these investments will lead to a real war in space between nations, but it will be a deterrent from countries kind of conflicting with each other and using space as a domain of warfare.
India has done a lot to explore with the means of orbiters some of the inner solar system planets and components, but we've yet to send an orbiter or any kind of mission to beyond the asteroid belt. Is there any reason for that? Can you shed some light on why that is?
One of the major blockers, assuming an intent, would be power, essentially, because at Jupiter and beyond, the sun really dwindles in the amount of power that you get there. And so because it essentially follows the inverse square law, so basically if you are since 5 times farther away from the sun than Earth is, then your power you're getting is 25 times less, and it only continues to get much more worse. The same thing that would allow you to survive the lunar night would allow you to explore the outer solar system. And so that's a common thread, and which is one of the reasons why China is now thinking about outer solar system, because they have already proven the surviving the lunar night challenges. Our GSLV Mark III, which is the most powerful rocket that we have, and that is only operational since a year or so now, is can put essentially 10,000 kilograms in low Earth orbit. And if you extend it to the moon, Mars, Jupiter, and beyond, then the payload capacity just drastically reduces. And and the outer solar system missions tend to be heavier. And even the most compact mission that has been ever sent to the outer solar system was New Horizons, that gave us our first look at Pluto, was 500 kilograms approximately, and that was very compact. So the fundamental problem here, apart from power, would be having a capable enough rocket that can allow you to venture out there. Of course, there we can always use gravity assists which is to basically grab momentum from other planets, Venus and Mars and Jupiter and so on, to go beyond. But it's not a magical thing, I mean, it can help you, but it can't solve fundamental problems per se. So a combination of developing a slightly more powerful rocket and using gravity assists would and of course the power would essentially allow us to explore the outer solar system.
Thank you. That's it from us.
So that was it, guys. I hope you enjoyed this session on Indian space exploration with me and Narayan Prasad for Tech2 First Post. If you liked what you heard, then check out my website for detailed stories on space exploration and the Indian space science spectrum. And if you really like my work, I would appreciate your support on my Patreon, the link to which is also on the website. So anyone can become a Patreon at a level that they are comfortable with and get benefits in return. So that's it for today, guys. Thank you so much. And if you want me to cover a topic in the future, just let me know in the comments below.